In Section 9.1, titled Talk to OpenAI within RStudio, the process for interacting with OpenAI's API using RStudio is outlined. Here's explanation. Initiating a POST request, the command response POST is used to start a POST request to the OpenAI API, and the response from this request is stored in a variable named response. Setting the API endpoint, the URL equals of api.openai.com/v1/chat/completions line defines the specific URL of the OpenAI chat API that the request will be sent to. Adding HTTP headers for authentication. Add headers, authorization equals paste, bearer, a PI key report, adds necessary HTTP headers for the request. Here, it includes an authorization header with a bearer token, which should be replaced with your actual OpenAI API key for authentication. Specifying content type. Content type JSON indicates that the format of the content in the request is JSON. Content encoding. The encode equals JSON part specifies that the encoding of the request content is in JSON format. Defining the request body. Body equals list begins the definition of the request body. This is structured as a list in JSON format. Selecting the AI model. The line model equals AI models determines which AI model from OpenAI will be used to process the request. Preparing the messages. Messages equals list, role equals user, content equals my question, outlines the structure of the messages to be sent. Each message is a list comprising a role, set, user, and content, which is the query or statement from the user. Can AI read the table? How about this? Or how can we do that? In this section, we'll discuss how to send an HTML table to chat and convert it into a character format. This is particularly useful when we need chat to analyze or process table data that's in HTML format. Let's break down the steps. In our demonstration, we'll explore how to convert an HTML table, specifically stored in a variable named myTab1, into a character format suitable for analysis by ChatGPT. Our approach is encapsulated in the following R code snippet. Working with an HTML table in myTab1, our starting point is myTab1, which contains our table data in HTML format. HTML tables are typically used for displaying data on web pages and are structured with tags like table, tr, and td. Reading and parsing the HTML table, we begin processing with the readHTML function. This function takes our HTML table from myTab1 and converts it into a parsed HTML document, making it easier to work with in R. Selecting rows from the HTML table, the next step involves atom nodes, ter. This function is essential for pinpointing each table row in our HTML structure. The tr parameter signifies that we're specifically interested in the row elements of the table. Extracting the textual content, lastly, we use HTML text, trim equals true. This function is designed to pull out the text from each row we've selected. The trim equals true aspect ensures we strip away any unnecessary whitespace at the start or end of our text string. The end product of this code is myTable1, a vector of characters, where each element is the textual representation of a row from our HTML table in myTab1. This character data is now in a format that can be efficiently processed by chat for any further analysis or queries. Through this process, we successfully translate complex HTML table data from my tab 1 into a simplified text-based format that's compatible with AI models like ChatGPT. In this part of our script, we're crafting a specialized query to interact with OpenAI's chat using data from a Shiny app. Let's dive into how we construct this query. Common question template, cumtemp equals C. Please summarize the results provided below, write it like a report document, and express it in sentences as a public health specialist. This is our standard query format. We're asking chat to summarize our results in a structured report style with the expertise of a public health specialist. This template ensures consistency in our queries. Additional information for context, add-in for equals C, WA1 Jeep is worried about work after finishing work. Here, we provide additional context to chat. In our table, we have the term WA1GP2, but chat doesn't know its meaning. By adding this information, we clarify that WA1GP2 refers to concerns about work after work hours. This helps chat understand the data more accurately and provide a relevant summary. Formulating the final query, my question equals sprintf%s. Consider my special request of %s. Result is %s, cumtemp, add-in for paste, metabolone, collapse equals. We combine our common question template, cumtemp, the additional information, add-in for, and the process table data, my tabalone, into a single cohesive query. This query is now ready to be sent to OpenAI for an insightful analysis. Sending the query to OpenAI. Here's how we send our prepared query to OpenAI's API. This block of code executes the POST request to OpenAI's chat API. We already discussed that. We provide the necessary headers, including a PI authorization, specify our content type, and encode our request body, which includes the model to use, a temperature setting for AI response variability, and our prepared query, my question. Let's put it together in Shiny apps. Observe event, input A, submit IE. This sets up an observer on the Shiny server. Whenever the input a submit AI element, likely a button, is clicked, the code inside the curly braces gets executed. Observe event is a common way to handle interactive events in Shiny apps. source/OpenAI source. This line sources an R script named OpenAI source from the source directory. Inside the observer, you have a function call to open a report with several parameters which is we previously discussed. Output a report 1 equals render text, testone. The result of the open a report function is assigned to output report 1 using render text. This means the output will be displayed as text in the user interface element that is bound to reportone.